Here's problem 37. The figure shows a cross-section of 3 parallel wires, each carrying a current of 5 amps out of the paper. If the distance r is equal to 6 millimeters, what is the magnitude of the magnetic force on a 2 meter length of any one of the wires? In this case, we got 3 wires, part of an equilateral triangle, and they're all going in the same direction. So they're all going to be moving in the same direction, having an attractive force between each other, and the distance between them, r, is 6 millimeters, and that's the same on all sides. So the way we're looking at this is by symmetry. The force on each wire will be the same no matter what. We could transform this by rotating this whole configuration around and replace one wire with the other, and we wouldn't know the difference. So each wire is going to experience the same magnitude force, and it's going to be an attractive force to each of the other 2 wires. So as we look, let's just choose this top wire here. There will be a force, let's call it F1, pulling it down towards wire number 2, and then there would be another force F2 pulling it down towards wire number 3. So let's call this wire 1, 2, 3. The force, the magnitude of each of these forces is going to equal mu naught I1, I2 over 2 pi d. That would be the force per length for any of these forces. So F1 is going to equal F2. It's going to equal mu naught I times L over 2 pi d. So that's going to be 4 pi times 10 to the minus 7 times 5 amps times 5 amps times 2 meters over 2 pi times 6 millimeters and what does that equal to? 1.67 times 10 to the minus 3 newtons. So each of the magnitude of each of those forces is 1.67 times 10 to the minus 3 newtons. We want to add them together, and if we notice, by symmetry, the x components of these forces are going to be equal and opposite. So they're going to cancel out, and only the y components will survive. And we're going to have 2 y components added together like this. So our net force is actually going to equal 2f sine theta, where theta is this angle right here. It's the same as this angle in this triangle up here. So 2f sine theta. Theta is equal all 3 angles on the interior of this equilateral triangle, so theta must be 60 degrees. So our net force is going to be 2 times f, 1.67, times 10 to the minus 3, times the sine of 60 degrees. And that's equal to 2.89 times 10 to the minus 3 newtons. In a down direction. So if we wrote this as a vector, our net force, as we're looking at it, would be a negative 2.89 times 10 to the minus 3 J newtons, as we're looking at this force. But it would be the same magnitude force on any of the other 2 wires for a 2 meter length. 2.89 times 10 to the minus 3 newtons.